Hello everyone. Today we are going to talk about the analyzing suicide rate with the socio-economic and demographic factor for risk prediction. Then let's talk about the sampling and data collection.
Sampling frame. The dataset includes 27,820 suicide records from National Health Department and International Public Health Organization covering the period from 1985 to 2016. Sampling design. A sample random sampling method was used to select 500 records from the dataset for analysis. Data collection. The dataset is publicly available and includes the following variables. Include some categorical variable, include country, sex, and generation. And numerical variable include suicide rate, GDP per capita, and population by country or age group. Possible bias, selection bias, inconsistent or incomplete reporting of suicide data across different countries may result in inaccuracies. Some countries may underreport or misclassify suicide due to social stigma or to avoid negative perception about mental health issue. Response bias. Inaccuracy could arise if individuals, like friends, family, or something like that, providing data offer incorrect information about a victim background, such as overestimating or underestimating the country's GDP based on personal perception or cultural factor. Governments may also manipulate GDP data to shape international perception.
Let's talk about the part 2 about the data analysis. That in this part we divide two data about. First is a univariate and the second bivariate. So then I'm going to talk about the univariate data analysis. Our objective is to explore the relationship between the country of the individual who's committing suicide and their generation background. So for this analysis, we involve the two categorical variable about the country and the generation, and another one about the numerical variable. This pie chart shows the distribution of the suicide across the various countries. That in this data reveal the slight variation between the country, with the island showing the highest distribution of the case. And another one of the categorical variable is the generation. Is focus on the number of the suicide across the generation, and we use the cutter bar chart to display this data. And this generation we included the such as like TI generation, silent generation, boomer, generation X, millennials, and generation Z. Thus, the Generation X has the highest number of the cases. Millennials come next with slightly fewer cases than the Generation X. Other generations like Boomer and the Silent Generation have lower number. And Generation Z has the fewest cases overall. So finally, this chart shows how the suicide varies by generation group, with the noticeable difference between them, that emphasizing that Generation X is significantly higher than Generation Z.
The univariate numerical distribution highlights that most populations experience low suicide rates, as indicated by the median. It is right-skewed shape suggests the right-skewed shape suggests a small number of populations face disproportionately high rates, which signifies inequality in the factors affecting suicide. And as we can see on the next slide, we use the histogram graph for the shape, which shows us that the distribution is right-skewed, the median rate is suicide, and the equatorial range between 0.912 and 1402, and the potential outlier that we observe in the interval, which would be the 106.5 to 113.6.
This analysis focuses on the relationship between GDP as the independent variable and suicide rate as the independent variable. The goal is to explore whether a country's economic status has an influence on its suicide prevalence. We have used the scatter plot for visualization and regression analysis to study this. Here in the scatter plot, we see that the direction is negative, which means that as GDP increases, suicide rates decreases. The strength is weak, the form is linear, and the possible outliers are marked in red. Our correlation coefficient is minus 0.04, which indicates a very weak negative linear relationship between GDP per capita and suicide rates in our data. Here we have our regression analysis Excel output in this slide to use the data here to see if we can generalize our results on a population level. The highlighted in yellows are the important parts that we use for our three-step procedure for correlation analysis. In our null hypothesis, we had the fact that the GDP per capita and suicide rates per 100K population do not have a linear relationship among all countries, and the alternative is that they do have a linear relationship. Our sample size was 500, and looking at the table that we have, the p-value for that is 0.139. And the correlation coefficient is minus 0.0418. So since the p-value is not in the rejection region, we fail to reject the null hypothesis. We have sufficient statistical evidence to conduct that GDP per capita and suicide rate per 100K population do not have a significant linear relationship among all countries. Which means that the complexity of suicide as a public health issue, suggesting that economic factors alone are insufficient to explain these variations.
Bivariate categorical data analysis. The objective of this analysis is to examine the relationship between the sex of individuals who committed suicide and the generation to which they belong. Proportion of sex among individuals committing suicide, bar graph and pie chart are shown. Females represent a slightly higher proportion compared to males. Proportion of sex among individuals committing suicide, Generation X accounts for the largest proportion, followed by the silent generation and millennials. Other generations such as boomers and Generation Z contribute smaller percentages. Side-by-side bar graph. Among females, the Generation X exhibits the highest proportion, significantly surpassing other groups. In contrast, male shows balanced representation with notable peaks in Generation X, millennials, and boomers. Female data demonstrates greater variability, while male data reflects a more uniform distribution across certain generational groups. Both genders show relatively consistent trends for groups like millennials and silent, but there is a distinct divergence in how each gender is represented within specific generations. Here is our chi-squared analysis. On the upper portion is the observed frequency, and on the lower portion is the expected frequency. Our H-null hypothesis is that sex and generation are independent of each other among all who committed suicide, and our HA hypothesis is that sex and generation are not independent of each other among all who committed suicide. With the values we obtained, we can therefore say that we do not have enough statistical evidence to reject the null hypothesis. Conclude that sex and generation are significantly independent to each other among all who committed suicide.
To conclude this project, the overall result was conducted with a univariate analysis of two categorical variables, graphs, and descriptive statistics to summarize and interpret these variables. A T-squared test was conducted and concluded that sex and generation are significantly independent among all individuals who committed suicide. Selection bias and response bias were also considered for potential misrepresentation. We also examined the bivariate numerical correlation analysis and used the three-step procedures, and with the analysis result, we failed to reject the null hypothesis, providing no evidence of a linear relationship between these variables. And the overall analysis of the dataset, which included 27,820 total records and 500 randomly selected samples, revealed that the small sample size significantly impacted the results. However, this limitation did not stop us. Despite this, all statistical procedures were followed appropriately to achieve the best possible result under the given constraints. Of course, further improvements for this analysis would require a larger sample size to enhance accuracy and the reliability of conclusions.
Thank